Okay, so in this video, we're going to go through some revision notes for Physics 0625 Cambridge IGCSE for Topic 2, Describing Motion. So let's begin. To begin with, we have quantities. In physics, we have two types of quantities, a vector quantity and a scalar quantity. A vector quantity is any quantity that has magnitude and direction, while a scalar quantity, on the other hand, is a quantity that has magnitude but no direction. So scalar quantity is simply a quantity with no direction. Vector quantity is a quantity with direction. Examples of vector quantities includes fields, forces, momentum, acceleration, velocity, and displacement. Examples of scalar quantity include time, temperature, power, and speed. These are just some common examples, but there are more examples. So again, two types of quantities, vector and scalar. Vector quantity has magnitude and direction. Scalar has magnitude but no direction. This is just an introduction to quantities. Now we're going to take each quantity in detail. To begin with, speed. Speed is the distance an object travels per unit time. So the distance traveled by an object in a specific amount of time is the object's speed. Speed is scalar because it only contains a magnitude without any direction. Formula of speed is distance per unit time, distance traveled per unit time, so it's distance divided by time. By symbols, V is equal to d over t. V represents speed, d represents distance, and t represents time. Speed is measured in meter per second, meters for distance, and seconds for time. Distance is meters, time is seconds. The formula triangle for this one is dst, distance up, speed down, and time down. So distance is equal to speed times time, and time is equal to distance divided by speed. And speed again is distance divided by time. This speed, distance over time, is specifically known as instantaneous speed because this is the speed of an object traveled in a moment of time. We have another speed that is the average speed. Average speed is the speed over all the distance divided by over all the time. So the total distance covered by an object divided by the total time, while the instantaneous speed is a specific distance divided by a specific time. So average speed formula is total distance divided by total time. These are some other units for distance, time, and speed. Distance can also be measured in kilometers. Time can also be measured in hours or minutes. Speed can be measured in kilometers per hour. So up till now, we've covered the introduction to quantities and the two types of speed, instantaneous speed and average speed. Now, how do we know how small or large the speed is? Distance time graphs help us do that. Distance time graph is a graph that tells us how large or small the speed is. In a distance time graph, the speed, which is the main core of the distance time graph, is the slope of the graph. And as you know in math, slope is rise over run, y2 minus y1 over x2 minus x1, change in y over change in x. The rise is the distance and the run is the time. So distance time graph, speed is equal to slope, and the slope is rise over run. Rise is distance, run is time. Here's a demonstration. This is the distance time graph where the distance is on the y-axis and time is on the x-axis. The rise is the distance covered, and the run, horizontal one, is the time covered. So we have types of distance time graphs. The first one is when an object is at rest. When an object is at rest, the distance time graph is a straight line from the y-axis. This means the object has no speed because the object is stationary. The second one is an object moving forward and upward at a constant speed. To tell if the object is moving forward and upward, it's a straight line through the origin. Constant speed because the line is straight. The third type of graph is an object moving forward and upward, again, line through the origin, but increasing speed because the graph is curved. So whenever the graph is curved, the speed is changing, either increasing or decreasing. If the graph is a straight line, the speed is constant. It's moving forward and upward if it's a line through the origin. It's moving backward and downward if it's a line through the beginning of the y-axis. The fourth type of graph is an object moving forward and upward because it's from the origin, but decreasing speed. Graph is bending backwards. So again, the first four graphs, object is at rest, stationary, no speed because the graph is horizontal. Object is moving forward and upward at a constant speed. Object is moving forward, upward at an increasing speed. Object is moving forward, upward at a decreasing speed. Now let's see the negative gradient graphs. For the negative gradient, we have object is moving backward and downward because it's a straight line from the y-axis at constant speed. The line is straight. Object is moving backward and downward at an increasing speed. Backward and downward because the line is coming from the y-axis. Increasing speed because the graph is going like this, away from the y-axis. Object is moving backward and downward again because it's from the y-axis at decreasing speed because the graph is closer to the y-axis. So again, for the negative gradient graphs, we have the object moving backward and downward at constant speed because the graph is straight. Backward, downward, increasing speed away from the y-axis. Backward and downward, decreasing speed closer to the y-axis. And that's it with all the graphs. Now, how to differentiate the steepness of the slope. A steeper slope means a larger and faster speed. Steeper slope is a slope or line closer to the y-axis. Shallow slope is smaller or slower speed. This one is the slope or line that's closer to the x-axis. The slope of the straight line represents its magnitude of speed. If it's closer to the y-axis, it's fast. Shallow is slow because it's closer to the x-axis. Now, what if the graph is curved? If the graph is curved, then increasing slope or increasing speed is when the graph is curving upward, away from the y-axis. Decreasing slope or decreasing speed is when the graph is curving downward, closer to the y-axis. So again, closer to the y-axis, speed is larger and faster. Closer to the x-axis, speed is slower. This is for constant speed gradients. For changing speed gradients, decreasing speed is closer to the y-axis, increasing speed is closer to the x-axis. To calculate distance time graphs, the rule is very simple. Rise is the change in y values and run is the change in x values. Rise is distance, run is time. So the speed is the gradient and the gradient is rise over run, distance over time. So let's take this example. A distance time graph is drawn below for part of a train journey. The train is traveling at a constant speed. Calculate the speed of the train. So we have a distance time graph. In this distance time graph, we know that there's a train and the train is traveling at a constant speed. Constant speed because it's a straight line through the origin. The run is 1, 2, 3, 4, 5, 6. The SI unit is minutes, so 6 minutes. The rise is 1, 2, 3, 4, 5, 6, 7, 8. 8, the unit being used here is kilometers. The rise is 8 kilometers. So rise is 8 kilometers. This is the distance. Time run is 6 minutes. Let's convert both of them to their default unit. Convert kilometers to meters. 8 kilometers is 8,000 meters. 6 minutes to seconds. 6 minutes is 360 seconds. Now let's use the formula and substitute the values. The formula is speed is distance over time. Distance is 8,000 meters. Time is 360 seconds. So speed is 8,000 divided by 360. Speed is 22.2 meters per second. Simple. Let's look at another example. Jose decides to take a stroll to the park. He finds a bench in a quiet spot and takes a seat, picking up where he left off reading his book on black holes. After some time reading, Jose realizes he lost track of time and runs home. A distance time graph for his trip is drawn below. So there's a distance time graph, distance over time. So what's happening? At first, he was moving at a constant speed during A, then he sat for some time, then he continued moving at a constant speed. The questions: how long does Jose spend reading his book? There are 3 sections labeled on the graph, A, B, and C, yes. Which sections represents Jose running home? Okay. What is the total distance traveled by Jose? So, for the first answer, Jose spends 40 minutes reading because the difference between 25 and 65 is 40 minutes. So he spends 40 minutes reading because 40 minutes he was reading at stationary, and at B the graph is stationary. The answer to B. Section C, because the slope is steeper in C than A, so moving faster at C. As we see, both are moving at a constant speed, C and A, but C is closer to the y-axis than A, so C is steeper, and the steeper slope is the faster one. So during B, Jose is running home. The answer to C, 0.6 kilometers, given by final point of line. Okay. Now that we've covered speed and its examples, distance time graphs, and how to solve distance time graphs, let's jump to velocity. Velocity is the speed of an object at a particular direction. So it's the speed, distance over time, but with a direction. Velocity is a vector quantity because it describes both magnitude and direction. It's the same thing as speed. Speed also describes magnitude, but speed does not describe direction. Velocity just describes the direction. So for example, a car is moving at 15 meters per second. 15 meters per second is its speed. 15 meters per second south or north or west, this is its velocity. The formula of velocity is going to be skipped because it's not included in the syllabus anymore. Velocity can be positive or negative. Velocity can have positive or negative values because these values describe the velocity's direction. For example, a ball is thrown up at a velocity of 3 meters per second and comes down at a velocity of negative 5 meters per second. Respectively, the speeds are 3 meters per second and 5 meters per second. But the velocity is positive 3 and negative 5. Positive 3 defines that it goes upward. Negative 5 defines that it comes back. So velocity can have positive and negative values to describe its direction. That's all about velocity. Acceleration. Acceleration is an extract from velocity. It's the rate of change of an object's velocity. So the change in speed per unit time to describe how an object's velocity changes every second. Velocity is distance over time. How is this velocity changing over time, every second? This is its acceleration. So velocity is rate of change of speed in a direction. Acceleration is rate of change of velocity in a specific amount of time. Acceleration by formula is change in velocity over change in time, delta v over delta t. By symbols, a is equal to delta v over delta t, or delta v is also defined as final velocity minus initial velocity. Final velocity is v, initial velocity is u. So the final formula of acceleration, which we're going to be using, is acceleration is equal to v minus u over delta t. Acceleration is equal to final velocity minus initial velocity over change in time. The triangle formula is a delta v delta t. The SI units of acceleration is meter per second squared. Time is seconds. Change in velocity is meter per second. Acceleration is meter per second squared because we have meter per second and seconds. Second and seconds, so meter per second squared. Speeding up and slowing down. Acceleration of an object can be positive or negative. Again, acceleration also has positive and negative values because acceleration is also a vector quantity because it has velocity, and velocity has positive and negative values. So acceleration can be positive or negative depending on whether the object is speeding up or slowing down. If an object speeds up, it's increasing speed. It means it's increasing its velocity. This means it has positive acceleration. If an object is slowing down, is decreasing speed, it means it has negative velocity and negative acceleration. Negative acceleration is also known as deceleration. Calculating acceleration. So let's take a very nice example here. A Japanese bullet train deaccelerates at a constant rate in a straight line. So we have a bullet train, it's deaccelerating at a constant rate in a straight line. The velocity of the train decreases from 50 meters per second to 42 meters per second in 30 seconds. So its velocity was 50 meters per second initially. It decreased to 42 meters per second in 30 seconds. During 30 seconds, it went from 50 to 42. We have to calculate the change in velocity of the train, calculate the deceleration of the train, and explain how your answer shows the train is slowing down. Okay, part A, calculate the change in velocity. Velocity is, so the initial velocity was 50 meters per second. This was the initial velocity. Then it decreased to 42 meters per second at a period of 30 seconds. So the formula of change in velocity, delta V is equal to V minus U, final minus initial. 42 was the final, initial was 50. So the change in velocity is negative 8 meters per second. Now calculate the deceleration of the train. Deceleration, we know by acceleration, the formula is V minus U over change in time. Final minus initial over change in time. So the given, we have found the change in velocity, which is 8 meters per second. We know that the time is 30 seconds. So just substitute the values and find acceleration. V minus U was 8 meters per second. The time is 30. 8 divided by 30 is 0.27 meter per second squared. Since the answer is negative, this indicates this train is slowing down and it's deceleration. And a quick note to keep in mind, whenever the change in velocity is negative, the acceleration is always going to be deceleration. Okay, the last part about acceleration is defining the direction of acceleration. This one is a very confusing one, but I've simplified it into a very simple and easy understanding way. So if the object is speeding up or slowing down, how can we identify whether the velocity is negative or the velocity is positive? If the velocity is positive, what's up with the acceleration? Is it negative or positive? Does it change if the object is speeding up or slowing down? Let's have a look at that. So if the object is speeding up, the acceleration is in the same direction as the motion. The motion, by motion we mean the velocity here. So if an object is speeding up to the right, it has positive velocity and positive acceleration because it's speeding up. So its acceleration is in the same direction of motion. If an object is moving to the left, it has negative velocity and negative acceleration because, again, acceleration is in the same direction of motion. But if the object is slowing down is the opposite. The acceleration is in the opposite direction of the motion. So if an object is slowing down to the right, it has positive velocity. Velocity remains constant, but negative acceleration. If an object is slowing down to the left, it has negative velocity, but positive acceleration. Again, velocity remains constant, but acceleration is in the opposite direction of motion. If an object returns, so for example, a ball is thrown at the wall and it bounces back, the acceleration is backwards. If acceleration is perpendicular to the motion, the object will bend. So for example, you throw a water bottle and a ball hits the water bottle at a perpendicular angle. The object or water bottle is going to bend because the acceleration is perpendicular to its motion. And that is all about velocity and acceleration. Now, how do we define the acceleration? Distance time graph tells us how large or small the speed is. Speed time graph tells us how large or small the acceleration is. It defines the change in acceleration. This graph shows how the speed of an object changes over time as it moves. They have speed on the vertical axis and time on the horizontal axis. They can represent an object's acceleration and deceleration and its magnitude. How large or small is its acceleration or deceleration? So if the speed time graph is constant, a horizontal graph or line means the acceleration is 0 because the slope is the acceleration. So if the graph is horizontal, the slope is 0, so the acceleration is 0. But the object is moving at a constant speed. If it has a steep slope, a slope closer to the y-axis, the object is changing speed very quickly. It has a slope with high acceleration. If the slope is gentle or negative slope, closer to the x-axis, the object is changing speed very slowly and gradually. Low slope is equal to low acceleration. This one only applies for deceleration, by the way. So let's have a look at these speed-time graph slopes. If the speed-time graph slope is constant, so during this time first, the speed is 0, object is at rest, speed is 0, acceleration 0. Here we have constant gradient, so constant acceleration with increasing speed. Here we have no acceleration because 0 slope, 0 acceleration, but constant speed. Here we have, again, constant gradient, but it's negative, so constant deceleration, but decreasing speed. Again, increasing speed is upwards, decreasing speed is downwards. Now, what if these speed-time graph slopes are curved? If it's curved, during part A, which is an upward curve, the slope is upward, so the speed and acceleration is increasing. B is the horizontal slope. This means the speed is constant because the slope is 0, and if the slope is 0, the acceleration is also 0. C is the opposite of A. During C, it's a downward curve, it's sloping downwards, so the speed and acceleration is decreasing. And D is horizontal, there's 0 acceleration and constant speed. How do you find the distance under the speed-time graph? The formula is very simple. Distance is equal to area beneath the speed-time graph. The area beneath the speed-time graph can either be of a triangle or a rectangle. Area of a rectangle is base times height. Area of a triangle is base times height divided by 2. Both represent constant velocity. So let's have a look here. This is a speed-time graph with velocity and time. For a triangle, this is a triangle. The formula is base times height divided by 2. This would be the base. This would be the height. Base, height, divided by 2. For a rectangle, this is the base. This is the height, divided by 2. No, not divided by 2. Triangle divided by 2. So let's take these two examples. To calculate for a rectangle, we have the calculate the area. Okay, so the distance is gonna be the area under the graph. The area under the graph is base times height. Our base here is 20. Our height here is 10. Base times height, 20 times 10, 200 meters is the distance. Simple as that. Calculate the distance for this one. This one is a triangle. Triangle is base times height over 2. Our base here is 10. Our height is 30. So area is 30 times 10 divided by 2, which is 150 meters. Simple as that. And this way we have covered everything regarding topic 2, describing motion, the types of quantities. We have discovered speed, how to calculate speed, its formulas, graphs to define speed, velocity, acceleration, describing acceleration, direction of acceleration, and graphs of acceleration, and how to find distance under a speed-time graph.